Hey guys, my name is David Sapala. I'm doing my extra credit for food chemistry, and today I'm going to be talking about phenolic compounds. The first compound we're going to talk about are the flavonoids. Now, flavonoids are in almost all plants. They're in fruits, vegetables, herbs, spices, tea, coffee, and they're actually a fairly ubiquitous compound because we have a daily intake of almost 1 gram. And they're important because they act as antioxidants, they'll scavenge oxygen-free radicals, they'll scavenge electrophiles, and they're also chelators of metal. Now, another contribution to food that they have is their color, and the color they typically give off is a white color. That's why potatoes, onions, and cauliflower, those are all white color. Now, flavonoids are all known because of their C6, C3, C6 structure. There are two main classes of flavonoids. You have your anthocyanins and your non-anthocyanins. For the non-anthocyanins, there's different classes, and those are based on the oxidation states of these 3 center carbons. You have your flavins, which will have an oxygen up here, which will change the oxidation state, and flavinones, which will also have a double bond to an oxygen at the bottom. Now, those oxidation states will kind of change the color. They'll make it more brown or black, and that will affect the color that we see. Now, polyphenol oxidase is an enzyme that can oxidize this because these are phenolic compounds. Now, another way that flavonoids will impart color on a food is by acting as a copigment, and this will contribute to the different hues you'll see in plants and their color in nature. An example of this is rutin, which is a quercetin, and it can complex with iron when it's in its ferric state, which is the +3 oxidized state, and this is what gives canned asparagus that greenish black color. But when it's with tin, it'll give the kind of attractive yellow color to wax beans. Now, flavonoids can also have an impact on taste. They're slightly bitter and contribute to astringency, which is that dry mouth feel you get, like when you have wine. We've talked about flavonoids. Let's talk about another phenolic compound, which are proanthocyanidins. Now, proanthocyanidins are similar in structure to the anthocyanins, but slightly different. They're typically going to be colorless, but they can gain color during processing. Now, their basic structure is similar to that of the flavonoids, but they'll still have the 0, but they'll have a hydroxyl group, typically here at the 2nd carbon. They're typically found in cocoa beans, apples, pears, fruits, and cola nuts. They will degrade under light into red, brown, stable derivatives, but they'll impart a reddish-brown color. And they're actually one of the main contributors to the color of apple and other fruit juices. They also will produce the astringency or dry mouthfeel, and natural proanthocyanidins can be hydrolyzed into common anthocyanidins in nature. As a phenolic compound, I'll try and just touch briefly on anthocyanins. Now, those are also pigments that are found in plants, and they give the red, purplish, and blue colors. Now, their color is based on their substituents, which is based on their structure. So they still have the same basic structure, but you'll have double bonds here, and you'll also have substituents off of the 3 carbons in the side phenol, and you'll also have a final substituent off of the 2nd middle carbon. Now, this will affect the color by the number of double bonds and the substituents. These are typically to be hydroxy or methoxy substituents, and down here it can be hydroxy, methoxy, or you can also have a sugar as a substituent down here. And when you have a sugar down here, it's called an anthocyanidin. You need to be careful with anthocyanins during production and processing because they're easily destroyed. You have to be careful with the pH. They're more stable at a lower pH, but as you increase the pH, they'll lose their color and then start giving off the bluish characteristics. They're easily destroyed during high temperatures. You have to be careful with oxidation because that can cause browning colors and also change with the oxidation states of these central carbons. You need to be careful with ascorbic acid because if ascorbic acid is oxidized, it can act as a pro-oxidant. And you also need to be careful with metals because this, as a part of the flavonoid family, it will act as a chelator. And if there's metals in the can, it'll start forming a purple or gray color from the complex. And this is one of the reasons why we have enamel-coated cans for canned fruit, is to prevent those off colors. So you need to be careful because they're easily lost during processing. Okay, another phenolic compound we're going to talk about are the tannins. Now, tannins are also polyphenolic, and some of their characteristics are they're H2O soluble, their molecular weight's between 500 to 3,000, and they can combine with proteins and other polymers like polysaccharides and precipitate alkaloids, gelatin, and other proteins. Now, they're found naturally in the bark of oak trees and fruit trees, and their range can be from a yellow whitish to a light brown. Now, I won't be drawing them because they're classified based on their characteristics, not so much their molecular structure, but they also will contribute to the astringency, and they contribute to the color of tea during fermentation. And another main use of them in the food industry, at least, is as clarifying agents because they can precipitate protein. Okay. The final phenolic compound we're going to talk about today are the betalains. Now, betalains are a pigment that contain beta-cyanin and beta-xanthin. They're not flavonoids, they're not anthocyanins, they're their own separate compound. They're actually chemically a derivative of tyrosine, and they're actually a glycoside and consist of a sugar and a color portion, and that color portion has a nitrogen, but they are phenolic compounds. They're also water soluble, and they're actually fairly pH stable between the ranges of 4 and 7, although 4 and 5 are best. If they lose their color due to pH change, they can regain it if they return to a 4 to 5 pH solution. And they're also thermally unstable. They'll lose their color during thermal processing, but they also can gain it back by going into a 4 to 5 pH solution. They're also oxygen sensitive, so you need to be careful, say, with the headspace of canned beets and try and reduce their exposure to oxygen, and it would be helpful to package them with an antioxidant. They're also a little unstable if they're packaged along with sulfur-containing compounds, so you got to be careful with what you add to a food that has a betaline to make sure it doesn't contain sulfur or it will lose its color. Okay, well, I hope you've learned a lot about phenolic compounds. I hope this helps you guys study for the final exam. Thank you, Dr. Lana, for the opportunity for extra credit, and good luck.